Okay, for today's lesson on areas of triangles and parallelograms, make sure you take out your notebook and put this on page 36. So grab a blue template, geometry template, that will help you with drawing the pictures for today. All right, so page 36, and our lesson is 11.1, areas of triangles and parallelograms. The main point today is just to give you formulas. These should look very familiar. Hopefully you've seen these in grade school. It's just another reminder of the basic formulas for triangles, parallelograms, mostly squares, rectangles, and parallelograms for today. All right. So for triangles, we can categorize them into three different triangles that we usually see. So triangles. Triangles have a very basic formula. Area equals 1/2 base times height. Now the key point is base and height must make 90-degree angles. So how is that different in different triangles? Well, let's see. The first type is an acute triangle. So acute, all right? So on your template, I would suggest that you grab triangle number 16. Number 16 is a very good acute triangle. I don't want it to be super specific like an equilateral or an isosceles. So this one is very, very generic. This is an acute triangle, all right? Now, the triangle's base must make 90 degrees with the height. So typically what books would do would pick one side to be the base and then make sure that you draw a 90-degree line from one of the vertices down and call this the height. We did this a while ago. We call this altitude. So altitude and height are very much the same thing. So typically an acute triangle, the height is on the inside of your triangle. The second type of triangle is the right triangle. A right triangle, I would suggest you to use template number 8 and trace that triangle out. Template number 8 will allow you to draw a very nice right triangle. And typically a right triangle should have, of course, a right angle. So since that's already a right angle, most books will remind you that, hey, one of the legs will be your base and the other one will be your height. We don't do anything with the hypotenuse, of course. All right. The third one gets a little tricky. The third one is the obtuse triangle. So in an obtuse triangle, it is leaning out. So we're going to use template number 13 to draw obtuse triangle. And notice on my template, I actually gave you a very good point here, literally a point. So if you use your pencil or pen and just dot that right there, what that tells you is that the obtuse triangle, this is really my base. This is the base of the triangle. But if you take your ruler and extend it out, you will see that this is where the 90-degree meets. So what is very typical of an obtuse triangle is that the height is on the outside of your triangle. Now, we don't really count for this shape, this region here. This is just the true height. Even though my triangle is leaning, if you were to sort of push it straight, that would be the height that it really actually makes with the base. So the base, even though it stops here, that's why we don't count for this region. The base really stops here, and your triangle is really counting on this base and this height. All right. So who falls under the family of parallelograms? So parallelograms has a few different shapes, right? We already did this earlier in the year, right? So we're going to start with one of the very basic shape we see a lot, square. Now, if you look to your template, that would be number 3. Number 3 is a perfect square. So tracing that out, you will see that as you're tracing it out, square has a very unique trait that all the sides are the same. So for a square, all you need is just one side, and your area is just take that one side and multiply itself because it's literally the base times height. Of course, it has a generic formula too, but it doesn't really apply to this one because the square has both of them being the same. Rectangle, then, it's very, very similar to our square. Using template number 18, you can draw your nice rectangle, right? Just like the right triangle, you notice that all the angles here are right angles. So it really doesn't matter which one you choose as your base and which one you choose as your height. Because in a rectangle, area is simply base times height. All right. parallelogram will act the same way too. So parallelogram. Parallelogram, I'm going to use template number 18 to give me a very good idea of what this picture looks like. As you're tracing, you can see there's that little dot again, just like our obtuse triangle. So just to remind you of a few things here, okay? So in a parallelogram, this is my base again. But now my base can have height in a few different places. It can be smack dab in the middle of my parallelogram. It can be right here at this corner, or it can be out here just like my obtuse triangle by extending this out. But notice the similarity between all three of these. They're exactly the same and they all make 90 degrees with my base. So these are all heights. They're all the heights. And area is still base times height. So for a rectangle and a parallelogram, they have the same exact formula, base times height. All right, I hope this will help you with your homework tonight. Don't forget, this homework tonight will go on page 37 in your notebook.